throttling was reduced to quite a degree, and you can see from the range of 100 to 350, the throttling has been between 3.3 to zero point 0.5. So an average 1.9 as against 5%. So this gives obviously much benefit efficiency. Also, the walls are more maintained with less throttling. So this was the reference of a plant in Germany, Franken. So, and we refer to then the plant Jowosno in Poland. And now here there was so this is a big power station, and this unit 3 was a coal-fired plant, coal-fired power plant with 6 steam turbines of 225, and run by this company Tauron Group. Here, and go to the next slide. Here, what we understand is this particular this agency, you can see NCBIR. So they had this special program of 200 plus, and this the whole intent was to ensure through technology that the life of these units are running and they meet the generation efficiency and emission targets of the EU level. So as a special measure, this Blocky 200 plus was launched specifically for the 44 units of this class in Poland. And we as Siemens Energy, we partnered with Rafaco and made the modernization efforts at these plants, and especially Unit 6. And the net result we have already shared last number of, some successes last time. But the success that is relevant to our topic of the webinar today was that we improved the flexibility to meet market demand. Also, the performance gains towards their demand from from the ministry. The EU ministry had those targets. We could achieve them, and after all that, we're talking about part load. So unit efficiency at 60% load was improved by almost 2%, which is a big requirement. And also for most power plants in India, this is one of the big concerns that when you are asked to run at min load as requested by the authorities, you will face a loss in efficiency. This is true, yes, but by measures that we implement, we can reduce this loss in efficiency and give you better returns and make you more comfortable even at operating at lower loads. Then we have summary of some of the plants. And here, Franken and Yawanso, we already spoke about. Some more units, Antelope Valley, units 1 and 2, 2 units of 470 megawatts, where we improved the efficiency at part load and also reduced the NOx by 6%. So again, this is here what we did was the principal reason for implementing and reducing improving the efficiency was implementing the combustion optimization. As mentioned by Bernard, combustion optimization, we have a very holistic approach. Depending, we would take a choice of the digital twin or the other two methods that we have to see which solution best fits that plant. Besides that, Atlas Energy in Turkey, so we have achieved 4 to 6 in the range of 4 to 6 Kelvin higher steam temperature, which gives them a better heat rate. And the other 2 units we did see some time ago. Also, we have references.
Ian, I'd like to add one more point, which is interesting on the Antelope Valley unit, because we optimized their load range, starting from 70%, which was a low load for this lignite plant, to 100%. And what we have seen there, that the improvement of efficiency at part load is much bigger, 2 to 3 times bigger than for base load. For NOx, it's the other way around. It's only 6% compared to up to 20% at base load, which indicates that if you optimize part load, then in many cases the improvement potential is pretty big, and oftentimes much bigger than at base load.
Oh, thanks. That is very interesting, and I think very encouraging to most of the power plant persons who are on the call, I'm sure. Then we go to, so yes, Bernard represents Siemens at the headquarters. He's a product manager and he's been involved in the solutions all across the world. While we have a major Indian audience, we would like to specifically focus what Siemens has done in this field in India. So Dadri, we did this test, wind load test a long while ago. Then we implemented solutions. We implemented solutions in combustion optimization and mill scheduler. We did the temperature optimizer and the condenser throttling and fatigue monitoring. All in all, we gave them a solution where they are able to run at a minimum load. They are able to run more efficiently. The mill scheduler, which was in manual mode, was taken into auto mode. The mill operation was taken from manual into auto mode, and a mill scheduler implemented. We even implemented single stream operation, and the temperature optimizer was parallelly implemented there. So all in all, multiple solutions giving them much request and benefit to operate comfortably at minimum load. In the other two units, Maithon and Andal, we partnered with CA and IGEF to conduct tests to conduct minimum load tests. These were detailed wind load tests done over a long period of time. This was the CA's initial efforts to make the test, to do the test and see before they go into the notifications for the country. So this was followed by a detailed report by all bodies involved and a recommendation what can be done to have sustainable wind load operation and better ramp rates. One of the examples where we are supporting with flexible operation and minimum load is Mundra, where it's an 830 megawatt plant. Here we are specifically focusing on combustion and temperature optimizer. We have done min load test here, and the tests have been satisfactory with some indications what we need to do. Out of that, combustion and temperature optimizer have been implemented, and a couple of more solutions have been indicated in the report, which we would be implementing soon over there. This is in a nutshell specific focus on India. There are some more examples, like we have done some 210 megawatts, 660 megawatts. That's not mentioned here, but that is pretty new, something that we did last week only at a 660 megawatt plant. So that's from me. So I wrap it up with all the examples. So back to you, Bernard, and Dr. Bernard, Dr. Claudia.
Yeah, so thank you for your attention and your questions so far. Now we have some time to answer more questions, and Ian, Dennis, and I look forward to do so.
Bernhard, there is one question in the chat, and I was going to answer it, but I actually have no further information. It's related to biomass co-firing. I'm not sure whether you can add some special facts here. So the question
is... You go ahead with the answer, and if I have something else, I'll let you know.
So the question is for biomass coal firing in coal-based power plants, if there are any estimations of O&M cost, heat rate, efficiency for those plants operating in this mode for base and part load. I think I answered the question in the chat. So we have screened some international studies and found this generic figure that the increase of O&M costs or operating costs in cycling operation is in average 2 to 5% compared to baseload operation. This is a very generic figure, so I think one cannot apply this for every plant, so it's very plant specific. And I would assume that the same applies for biomass coal firing. with regards to heat rate and efficiency in part load as well as for the cost. So I don't see any specifics here if you do biomass co-firing. But now I would like to hand over to you, Bernard, Dennis, and Ian, if you have some insights.
Thank you, Claudia. It's absolutely correct what you told now. We provide the feasibility study up to, I think, 5 or 7% biomass co-firing in existing coal plant in Indonesia, in Maithon. It was at first to see what is impact to the thermodynamic, to efficiency. Yeah, everything under 10% doesn't have any big issue, doesn't have any big impact. Yeah, I think it is not point of concern. Point of concern is here the stability of combustion, stabilization of combustion, physical and chemical parameters in order to protect, for example, any corrosion, CO corrosion effects or flow corrosion